So a lot of these are concepts we haven't seen before, so I'm going to do my best to help walk you through these without giving you the answers. Okay, so we're comparing it to the unit circle here. We're asked for which of these is closest to the measure of the angle that we're being shown here. So this angle that's being shown on the terminal side, what is that compared to all of these? So it's good to kind of recognize what's going on here. So this would be 0 or 2 pi. This would be pi over 2. And this is pi. And this is 3 pi over 2. The technique I would recommend would be to have a common denominator. And then once we have a common denominator, we can see which ones of these kind of fit in between it. Also, we can look at the idea of, is it half of it or is it a full? Is it 3 halves of it or is it 2 wholes? Okay, so as we look at this, let's go ahead and take a look at this one. Is this one, is the 3 more or less than what half of 8 would be? All right, so half of 8 would land itself right here. So is 3 more or less than half of 8? Okay, if it's more than it, it would land here. If it's less than it, here. Okay, 3 halves, 3 halves. That would be kind of looking at it. Oh, that lands right here, right? So we can think, is that our answer? It lands right here. The 7 over 10, is that more or less than a half of 10? Is 7 more or less than a half of 10? And then the 7 over 20, is that more or less than a half? Okay, so that should kind of help you with figuring out. And if that doesn't, remember, you just make a common denominator and land it wherever it needs to. Okay, let's move on to the next one. Okay, where would this land? Same idea. Notice we have the pi's here, so this would be 0 and 2 pi, pi over 2, pi, 3 pi over 2. Same kind of game. I would recommend you have the option. Notice we have 6s or 4s here. So having a common denominator would really help to kind of compare where it lands on here. So remember, it starts going this way. And are we more or less than whatever we're kind of landing on, right? So here is 1 pi. And then you think about which one of these is a little bit more than 1 pi. And you have to kind of consider the fraction. So 11 pi's over 6. How far is that? Is that close to 1 pi? Or is it close to 2 pi? What is it close to? And we're looking for something that's just a little bit over 1 pi right here. All right, so if you're not sure, if you have something to compare with some of these, or remember, you would just have to make a common denominator and see where it lands with the common denominator. You want to have the same kind of unit. So you want to convert this, kind of the easy way of thinking about it. So our unit circle, and think about labeling it 0 and 0 pi. 0 degrees and 0 pi, and then labeling all of these, and that can kind of help you with which one's which. Okay, so you have to convert one of them into the other. So this is radians. This is degrees. And our converter is 180 degrees. Yes. 180 over pi, or pi over 180. Use that as a converter to see which one's bigger or smaller. You can't compare unless they're the same unit. What quadrant does this lie in? So it's that same idea. You just don't have the picture here. And sometimes you can go multiple times around. So in this case, I would think of it as how many times does 4 go into 21? And I would wrap it around that many times. So however many times 4 goes into 21 is however many times it goes around. Notice that we're in pi here. So this is pi, this is 2 pi. If I go around again, this is 4 pi. This would be 3 pi. If I go around again, this would be 6 pi. This would be 5 pi. And you can do it that way if need be. So you can do it manually or kind of figure it out through the cycles. Okay. Which quadrant would you find an angle measure? Negative 740. So negative means we're going the other direction. So now we're going in this direction. This would be 0. This would be 360 negative degrees. Notice we're in degrees here. That's why my circle is in terms of degrees. This would be negative 180 degrees. And you would just add negative 360 to this. So you need a calculator if I don't have that memorized. So let's do Desmos. So if you have negative 180, you go around the circle again. So you're going to add negative 360 to it. Okay, so negative 540 is the number I was looking for. So each time we go around, we're adding 360 or we're subtracting 360. Coterminal just means if this is our terminal angle that we saw, this would be called the initial. This is called the terminal. And then angle. And then anytime you go around it and you hit it again, that's the coterminal idea. So all the other angles that you go around in either direction that hit it. So for the coterminal, you're always adding or subtracting 360 degrees or 2 pi, depending on if you're in radians or degrees. So since this is degrees, you're adding or subtracting 360, and then you would just see which one of these land on it, but when you add or subtract 360. Coterminal to 45 degrees, so same thing, you're adding or subtracting 360 degrees to see which one of these land on it. Negative and positive coterminal, so in this case, you would add 360 and subtract 360. And you may have to do that multiple times if they're really big or small numbers to see where it lands. Reference angle. Okay, so these are a little bit more tricky. Reference angle. See if I can't help set it up. So we got 7 pi over 5. So we're in pi's. So 0 and 2 pi. This would be pi over here, pi over 2, and 3 pi over 2 over here. All right, so we have a 5 on the bottom. So I would want to make them both 10 common denominator. So this angle right here would be 14 pi over 10. And then I need to make each one of these into 10. So times 5 times 5. This is 5 pi over 10. This one is over 1. So times 10 times 10, 20 pi over 10. Times 5 times 5. This one is 15 pi over 10. And times 10 times 10, that would be 10 pi over 10. All right, so we have 14 pi over 10. So where does that land? In between what? So that would be 14 is between 10 and 15, so it's closer to 15. So right there, that's our 14 pi over 10. Coterminal, reference angle. It's just doing coterminals. Reference angle always goes to the x-axis, so we take it to the x-axis. And this is the angle that we're looking at right here. That's the one that we want. All right. So what is that angle right there? That's our question. So basically you would take the 10 pi over 10, subtract it from the 14 pi over 10, and then that's going to be your answer. All right. So you're always comparing it to the x-axis. Reference angle for 297. Same idea, but you're in degrees. That's a lot easier. So, we got our 0 and 360. We got our 90, 180, 270. These are all degrees. That 7 should not have a little tail on it. All right, it's a 7. It's a 0. All right, 270 degrees. So you would see where 297 lands, and then you would compare it to the x-axis. You'd subtract it from either 180 or 360, and that would give you your reference angle. Reference angle for 240. Hey, good thing I kept it up. So you do the same thing, compare it to the x-axis degrees, 180 or 360. Convert this into degrees. Do you remember what I said is our converter? You have 7 pi over 6, and you're either going to use 180 over pi or pi over 180 degrees. And the key to remember is you want the pi's to cancel. So you want to make sure you want to pick whichever one that has pi on the bottom, multiply straight across, and reduce. Same idea. Pick whichever one you want pi's to cancel. Same thing. In this case, you want the degrees to cancel. So you want the degrees to be on the bottom. So the degree unit cancels and you're left with pi. All right. Cosine of 4 pi over 3. So you would need to do the reference angle trick. I don't have these memorized. Some people do. So this is in terms of 3 as our denominator. So that would be n pi. So we got 0 and 2 pi. Got pi over 2. Have pi over here. And 3 pi over 2. Okay. Since this is a denominator of 3, you want to have a common denominator. So what's the common denominator with all of these? It would be 6. 6 would be the common denominator. So I'm going to go ahead and multiply this top and bottom by 2. So this is now cosine of 8 pi over 6. It's the same problem, just increase the fraction. So top and bottom multiply by 3 pi over 6. And top and bottom by 6, so that would be 12 pi over 6. Top and bottom by 3, so that'd be 9 pi over 6. Top and bottom by 6 6, so that would be 6 pi over 6. All right, so where does 8 pi over 6 land? 8 pi over 6 is in between 6 pi over 6 and 9 pi over 6. Right there. Doing a reference angle on this. And this is the angle that we're focused on. We're also in quadrant 3 here. So it matters because we need the signs. The signs for both of these is negative and positive. They're both negative in quadrant 3. So to do the reference angle, first we need to find this angle right here that we're talking about. This angle in pink. That's the one we need. And that would be, we're subtracting it from the 6 pi over 6. So 8 pi over 6 minus 6 pi over 6. We already have a common denominator. Subtract the tops. That's 2 pi over 6, which turns into pi over 3. All right. Pi over 3 is one of our special right triangles. So let's see, do we want to do that or not? Oh, no. Let's see what I'm trying to find out what the x and y is. So let's just see. For me, I think about it as sine over cosine is y over x. So cosine is the same as the x part. So this is the number that we want. This is going to be our answer. That's the x that we want. And notice it's also negative. So that's real important to kind of recognize this is our negative. Our answer is going to be negative. So it can't be this one and it can't be that one. All right. And let's go ahead and, let's see. How do I want to do this? Cosine 7 pi, I guess I'll use my special right triangles. 60, 30, that's 90. That's going to be 1, 2, radical 3. If I remember right. Let me just see if radical. I always remember. Sometimes I make mistakes, so just want to be careful. So radical 3. What is that? Yes. I was checking to see which side's bigger. 1, 2, 3, and the last one's radical, and the hypotenuse has to be bigger. So this is good. What is radical 3 as a degree? That's how I remember it. So I would go ahead and pi over 180, and it goes into it 6 times. So, and it cancels. The pi's cancel, so 60 degrees. Cosine is adjacent over hypotenuse. So katoa. So the adjacent from the 60, adj, the hypotenuse, and adjacent over hypotenuse, 1 over 2 is the answer. And then we want to remember it is negative. So negative 1 over 2. So sorry, I went ahead and gave you the answer on that one. It took so long and a lot of math to kind of get there. So gave you one. Same kind of setup on this one. So it should be very similar. You want to compare it, use sine, and kind of relate it to the reference angles. Radian measure that corresponds to the given coordinates points on the unit circle. Okay. Where does this land? On the x and y axis. So on the x and y axis, we got negative and negative. So that means it'd be around here somewhere. And what radian measure corresponds to it? Let's see. So the radian measure is going to be all the way around. Right there. Let's see. How do we want to do it? All right. This is the X. This is the Y. Right. So go ahead and just break it down this way. It's hard for me not to just finish it off, but I'll try not to finish it off this time. All right. And the X is negative radical 2 over 2. The Y is negative radical 2 over 2. And then I would use the Pythagorean. Oh, no, we don't need it. Let's go ahead and just look at tangent and arctangent. All right, so let's go ahead and find out what this degree is right here, theta. And then we would just add the 180 to it. Okay, so that's this theta plus 180 will give us the degree that we want. Once we have the degree, we would convert it back into the radian. All right, that would be how to calculate it. But I just want to recognize that you can also use that last trick, or my first trick of this is 0 and 2 pi. This is pi over 2. This is pi. This is 3 pi over 2. And see with the common denominators, which one lands in quadrant 3 here. So having some options makes it a little bit easier. If you do have several options, then you'll have to go through my trick. Okay. Exact coordinates of 3 pi over 4 on the unit circle. So 3 pi over 4 on the unit circle. All right, so just think about what we've been talking about. This is 0 and 2 pi. This is pi over 2. Brain's starting to fry a little bit. Pi and 3 pi over 2. And then you would think about these as the X and Y's and see which ones kind of land in the quadrant that you need. If there's more than one answer, then you would have to do the reference angle and calculate it that way. Hey, finally, some straightforward problems. So you just use trigonometry to find X. Inverse trigonometry to find theta. All right, so I hope these pieces of advice will help you get a better score on the quiz. Make sure you take your time, do your best, and try to get those answers correct.